This video will cover computing data summaries in dplyr. The R code and data used in this video are available on the Learning Management System. We'll use the weather2017.rds data file. You should download those now if you'd like to follow along. By the end of this video, you should know how to compute data summaries in R using dplyr, what some common dplyr summary functions are, and how you can combine these functions when computing data summaries. You're going to compute data summaries in dplyr using the summarize verb. This is like every other dplyr verb. It expects data as the first argument. This will generally be supplied by putting something on the left-hand side of the pipe and putting summarize on the right-hand side of the pipe. Summarize works very much like mutate. You're going to give it variable name equals expression pairs, and these are going to be separated by commas. However, summarize is different from mutate. Every time you use summarize, it's going to consolidate your data somehow. This means that the number of observations are going to change. The expression part of the variable name expression pairs is a summary value that's going to be computed over all of your data. Each row of the resulting tibble is going to be a summary of many observations from your initial data. These expression and summarize will always contain summary functions. We'll go over a bunch of them later in the video, but as examples here, the mean function computes the mean of a variable, and the SD function computes the standard deviation of that variable. Let's go ahead and compute some data summaries in R. First, I'll run my setup code. My first example is very typical of what you might use as a summary command in dplyr. I take my weather tibble, I pipe it to the summarize verb, and then I specify name expression pairs. In the first, I would like a variable mean temp equal to the mean of the minimum temperature variable. And in the second, I would like a variable SD temp equal to the standard deviation of the minimum temperature variable. Let's run that code. If you look at the output, I got something that maybe wasn't expected. I have NAs for both of the values. If you remember, NA values pass through our calculations. There are a couple of NAs in this weather data. So what can we do about that? Let's take a look at these NA values and see where they occur. I can do that using the filter verb with isNA on minimum temperature. You see that there are 3 observations where each of the temperature variables are missing. So what can we do about that? There are many options for dealing with missing data. Here, we're just going to drop them. I'll take my weather data, I'll pipe it through drop NA, and create a new tibble called weather.noNA, which will exclude the missing values. I'll do that. It's always a good idea to check to make sure you get what you expect. So I'll take a look at that weather.noNA tibble and filter on missing values to see if there's any remaining. Looking in the output window, you see that I have cleared out the missing values. So now we can try and compute those summary statistics again. I'll run that exact same bit of code that I had before. Looking in the output window, you now see I get a tibble with 1 row. It has a column called mean temp with the average value of the minimum temperature. It has a second column called SD temp with the standard deviation of that minimum temperature. An important thing we learned in this last video is that NA values are important when computing summary values. Remember, NA values are going to pass through most calculations in R, and summarize is no exception. As a result, if you have NA values in your data, you're generally going to get NA summary values. The only exceptions are summary functions that give values based on where they occur in the data set. Examples would be the first, last, and nth summary functions, which give the first, last, and some ordinal position value in your data. This means that if you have NA values in your data, you're going to get NAs, or sometimes NAN, which is a special kind of NA value, unless you filter them out or otherwise deal with them first. I've given you 2 examples of the summary functions you can use, the mean and SD functions. There's a wide range of summary functions you have available in dplyr. For measures of center, you have the mean and median functions. For measures of range, you have the min, max, and quantile functions. For measures of spread, you have the SD function, IQR, which computes the interquartile range, MAD, which computes the median absolute deviation, var, which computes the variance. For measures of position, there's the first, last, and nth. For measures of count, there's the n function, which just counts observations, and the n_distinct function, which counts the number of unique values. Lastly, there's other types of summary functions. The sum function computes the total of a variable. The any function is like running OR across a bunch of logical values, so it will return true if any value is true. Likewise, the all function is like running AND across all of your values. It will return true if all the values you provided are true. There's great online resources for these summary functions. In particular, the dplyr Summarize page is an excellent resource covering most of these functions. So here I just have additional examples of using summary functions with dplyr. Remember, you're going to take your data, pipe it to a summarize verb, and then specify name expression pairs of summary values you'd like to calculate. I have mean temperature that we've seen before. In the next pair, I compute the median of temperature, then the interquartile range. Total temp uses the sum function, which will calculate the total or the sum across all values of minimum temperature. And in the last example, second temp uses the nth function to tell me what the second value in my data set of minimum temperature is. I'll run all of that code. Looking at what we get, you see the same mean temp as before. The median value is 50. The interquartile range, the difference between the 25th and 75th percentile value, is 27. The total of all minimum temperature values is 17,139. And the second value in my data set, the value on row 2, is 37.4. Summarize is more flexible than computing just these basic summaries. You can include formulae in your summarize expressions, much like the mutate command. For example, suppose we want to compute the coefficient of variation. This is a statistical object that is the standard deviation of a variable divided by its mean. You can do that in summarize using the code that I have in the upper right. Again, I would say that this value, COV, I would like to be equal to the standard deviation of temperature divided by the mean of temperature. I have our code here that implements that calculation. To verify that we got it right, first I'll compute the average temperature, second I'll compute the standard deviation, and third I'll compute that coefficient of variation, which is the standard deviation divided by the mean. Let's run that code. You can see in my resulting output, the mean temperature is 48.6, the standard deviation is 15.5, and the coefficient of variation it computed is 0.319, which you can verify is 15.5 divided by 48.6. Looking back at my code, you can change these formulas in other ways as well. Suppose I wanted to know the average range of temperatures every day, the difference between the minimum and the maximum. Here in this next example, I take the maximum temperature, I subtract the minimum temperature, and then I ask R to compute the mean of that. Let's run that code and see what I get. Again, looking at my output, you can see that the average difference between maximum and minimum is 18.3. We've seen a couple of different ways that we can construct these expressions and summarize verbs. I want to emphasize the order of operations, exactly how you construct these, is important. So I want you to think about an example here, where I want to compute the summary value mean.1 as the average of max temp divided by min temp. Then I have a second expression, mean.2, computed as the average of max temp divided by the average of min temp. I can translate those into dplyr commands, which I've done on the right-hand side. In the first, I have max temp divided by min temp inside the mean function. In the second, I take the mean of max temp and I divide it by the mean of min temp. These will not give the same result in R. Let's think about why. So suppose in my data, I just have two observations. Max temp is 10 and then 20, and min temp is 5 and then 4. Using my first formula, I would compute the mean of 10 divided by 5 and 20 divided by 4, which is the mean of 2 and 5, which is 3.5. In my second formula, I'm going to compute the mean of 10 and 20 divided by the mean of 5 and 4. That's 15 divided by 4.5, which is 3.33. These are two different expressions that lead to two different answers. The important thing to note here is that the order of operations, precisely how you specify an expression in a summarized statement, matters. So you should think carefully when you're constructing these statements that use complicated expressions. Taking a look at this in R, I have here our code that implements something exactly the same as the slides using the variable names from our data set. So mean1 is the mean of maximum temperature divided by minimum temperature. Mean.2 is the mean of maximum temperature divided by the mean of minimum temperature. As we saw before, these can result in different values. Let's see what happens when we run this. And again, looking at my output, you'll see that the values of mean.1 and mean.2 are slightly different from each other because the order of operations in these summarize expressions matters. The summarize verb provides a very useful framework in dplyr for computing summaries of your data to get a sense of measures of center, variance, or position in data sets.